So I think, as you've hopefully sort of seen from this morning, we started off with co-design and also with diagnostics, so digital diagnostics, which sometimes form part of therapy apps and sometimes don't. So this afternoon we're going to move more towards digitising therapies, and then in the final session we're also going to look at trying to spin out, and we've already had a few questions on this, is you've got these great things, but how do we embed them in various healthcare systems? And the answer is it isn't easy. And one of the reasons for inviting Swathi is that she's done all of these things. So she's gone through every single stage. She's done the co-design, she's done diagnostics, she's done therapies, and she's spun them out in a company with her partner as the CEO, and has also got quite large data sets. So that was really a lot of the thinking behind inviting her, other than the fact that we also like her. So I'm going to introduce Swathi now. So she's a professor of neurorehabilitation and founding director for the Centre of Brain Recovery at Boston University, and she's going to talk about, I think, primarily about the digital therapy that she's come up with called constant therapy, which is for people with aphasia. So please help me introduce. Welcome, Swathi. Thank you.
Thank you, Alex and Catherine, for inviting me, and so far it's been a really great session, so thank you for inviting me to be a part of this symposium. So I would first like to acknowledge my funding. Most of it comes from NIH, as long as there's NIH at least. So far that's been the case, and as Alex mentioned, I do have to disclose that I have a financial interest in constant therapy, the software that I'm going to talk about today. Okay, and as he mentioned, today I'm talking about constant therapy. I have a whole other research area looking at neuroplasticity, but my role in this company is to be the main scientist. There is a large team around this that does all the software work. My role has been to help with the co-design, getting patient feedback, and deciding what the clinical applications and science is going to be. So that's what I'm going to try to focus my talk on today. So let's start with the problem. I'm pretty sure all of you know what the problem is here. People who've had a stroke can get rehabilitation, and these patients can get better, but the current care that they get is very poor. Here's an example of therapy in my lab from several years ago.
Apron.
Mm-hmm.
No. Balloon or whatever. Raft. Rapids.
Where you go on the rapids and that, right?
Yeah, exactly.
So it's paper-based. This is a semantic category therapy, and so it's pretty variable. And not only is this care kind of archaic, the care is actually very poor. This is a recent study that came out from the US showing that as time goes by, the amount of rehabilitation that patients get is very less. And if you look at the amount of speech therapy patients get, it's 8% between 6 to 12 months. And this is in the US, and I know the data in the UK is also similar. The other thing is that to improve skills, much higher intensity of therapy is needed, but it's not provided. So this is Marion Brady's 2016 Cochrane review showing that if studies that actually looked at high-intensity therapy found that the evidence for improvements favors high intensity. But this is not happening in the real world. This is a paper that literally just came out in Stroke by David Lin and colleagues who are all looking at motor recovery. And they're making the argument that high-dose, high-intensity stroke rehabilitation is what everybody needs, but still it's not happening in the real-world settings. So there has to be other solutions that come out here. And what I'm calling here is the progress cliff. So the current care is paper-based, it's variable quality, it's highly limited, as you've already pointed out. And what really needs to happen is optimum care, which is personalized, consistent, and high quality, continuous, and scalable to a large number of patients. So this is the problem that we were trying to solve, and that's how constant therapy came about, constant therapy. So I'm going to tell you a little bit about what this program is all about. You will get a chance to see the demo later in the afternoon because Vera will be here, but I'll give you a high-level drive test through. So Constant Therapy is a mobile app. It's something you can download on your phone or iPad or tablet, and there are two parts to it. There's the Constant Therapy app for patients, so the patients can download this app sign up and get personalized experience, and I'll explain how it's powered by an AI engine. There are automated assessments, and most importantly, there's therapy anytime, anywhere. So patients practice this at home. There's also a clinician version of this. It's called Constant Therapy Clinician. There's a whole database of exercises, about 1 million therapies, as I'll show you, across 91 categories. And the clinicians can deliver this therapy in the clinic or remotely monitor the patients. And what they get is performance reports and a large amount of data insights here. It does have, Constant Therapy at this point does definitely have the largest collection of digitized evidence-based speech and cognitive exercises. I'll show you some in a minute. We've spent a long time trying to decide how to digitize them. And this database has about 300 million exercises. Patients practicing this, everything goes into this database that's delivered across different patient populations, including stroke, traumatic brain injury, and dementia, although today I'm only going to focus on stroke. Behind all this is an AI engine called Neuroperformance Engine that monitors and analyzes this database to personalize exercises for each individual user. And more recently, Constant Therapy got the FDA breakthrough designation for stroke, basically saying that this is a high potential for FDA. At this point, it's being used a lot in the US, pretty much across most hospitals, especially rehab units, and most places where there is English-speaking populations. I'll come back to this if needed. Okay, so what is the Constant Therapy Neuroperformance Engine at a high level? It's a database that includes brain impairment therapy that is all these different tasks that patients have performed, and then it groups all the data based on performance of people with similar profiles. There's the user performance history as well as user performance preferences. So every time a patient practices a single exercise, it goes into this database, and their latency and the response time and their characteristics all get coded into this database. And then, of course, there's the clinician part to this as well. So the clinician inputs for the patient. So what a clinician thinks is important for the therapy and the context. Where is it being practiced, in the clinic versus at home? What time of the day, and so forth. So all this go into this engine algorithm. And based on that, it constantly provides new personalized therapy tasks for each individual user. So this particular technology is patented, and what's really important about it is that it's constantly updating the database in real time to produce the next patient's next therapy task based on that database. And as we're designing the therapy, we also made sure that it fits in with the rehabilitation treatment specification system. I don't know if you know about this, but in the US, a lot of therapy is designed to fit into this framework that is essentially trying to identify what are your therapy ingredients, what are the mechanisms of action of your therapy. So in this case, for example, the task variety creates a comprehensive therapy target across all these different domains. There's personalized goal setting for each individual patient, so there's more buy-in by the patient and the clinician. It's constantly adapting the level of difficulty, so that's also personalized. And so we sort of broke down every aspect of constant therapy into what we think might be actually leading to why patients improve based on these therapy outcomes. Is my pace okay so far? Okay, I tend to talk a little fast, so I just need to make sure it's okay. All right, so based on that, I just want to give you a high-level perspective of what actually happens in constant therapy, and then I want to spend the rest of the talk showing you about the data and the scientific evidence around that. So there, as I said, there's a patient aspect to it, and there's a clinician workflow to it. So going through the patient workflow first, the patient downloads the app, chooses what sort of domain they want to work on, remembering, memory, auditory comprehension. Then they first do a bunch of subjective assessments that basically asks them, how well are you able to do this right now? After they do this, they go through a bunch of objective assessments, actually testing them on how they're doing those different tasks. And then they start practicing the program. So it guides them through their level of therapy based on what they decided they wanted to work on and what their starting point was. And I think on a weekly basis or daily basis, they get an email saying, okay, here's how you're doing. You practice 24 exercises, keep doing, keep going, and so forth. The clinician experience is somewhat similar. In this case, the clinician signs up for the constant therapy. Now, we're talking about somebody in a rehab hospital. And they start enrolling their patients, and hopefully you can see they just start adding patients in this portal. And then for each patient, they can override the AI and assign what therapy they want for the patient. And I'll show this in a bit more detail in a second. And then they tell the patient to go practice the therapy. So the patient starts practicing the therapy either in the clinic or once they go home, they can practice therapy. And the clinician now gets this really detailed data of usage and practice as the patient's practicing either in front of them or when they're practicing at home. Now, there's certain things about constant therapy that I already told you were important in our framework for why we think this works. So I want to show you how it's applied into this particular software. And so these are things like the variety, the goal setting, the difficulty, the consistent feedback, motivation, tracking patient adherence, and progress. So you're going to see these themes show up again and again in my next set of slides. So first of all, task variety. We tried to put everything we knew worked in speech-language therapy into a digitized form into these categories. And so what I really just want to point out quickly, because you're not going to read all of these, is for any given domain, there's a different task that has multiple levels. And within each level, there's varying levels of difficulty, and the patients progress through that. So some of them have 12 levels, some of them have 2. And this is just the cognitive domain. In language, there's even more. And again, there's big domains. Within the domains, there are specific tasks. And within specific tasks, there are specific levels of practice. So here's an example. Hopefully this video works. So this is a simple cognitive task.
Read the time on the clock. Tap Start and say the time. The sound meter will show if you're speaking loud enough.
10 o'clock.
That's
When
the
you're
patient.
finished, tap Stop. You can tap on the clock to enlarge it. Tap on Close in the right corner to go back. If your response is marked wrong, you can mark it as correct or try again. If you want to hear your recording, press the replay button. To hear the instructions again, tap the small play button to the left of the text.
So
Read the time.
That's just how it works. As you can see, it's non-gamified, and we can go back to the discussion about why we decided to not gamify this. But here's another task. This is this is an attention task. This is again in the cognitive domain.
Memorize the first card that you see. When you're ready, tap Start. Tap each card that matches that first card in the deck.
Okay, so that's another example of a different task.
Memorize.
And here's an auditory comprehension. This is like the Western aphasia battery with varying levels of difficulty.
Listen to the instructions. Place the violin below the fan. Then place the orange to the left of the fan. For extra help, tap on the picture to hear the word.
So there's a whole bunch of cues.
To hear the instructions again, tap the small replay button.
There's a whole bunch of cues that the patient can get, but once they press the cue, the score docks down a bit because they use the cue, so it'll give a differential performance based on whether they use the cue or not.
Listen to the instruction.
Okay, so here's another example, but I don't need to go over it. There's just way too many exercises. But I think the key thing I want to point out here is that every one of these, you can pick which level and how many trials you want the patient to practice of that. So you get a sense of what this platform is about. Okay. So from the patient standpoint, what the patient can do is when they log into the app, they pick which domain they would like to assess. They can pick more than one, and it then sets up the starting point for these people from that place. And as I said, it's constantly doing this adaptive difficulty. So depending on what range of accuracy they're at, it'll say, well, you got this kind of right, so we're going to keep doing this. Or it'll say, well, maybe we'll try something different today. Let's go to a different domain. So it bases it based on that person's particular specific performance. And as you saw, the ding button when they get it right versus the incorrect button is giving them constant feedback. And actually, patients can see the progress that they make. So here's a patient who was practicing constant therapy for 10 weeks.
What I want you to do is just tell me about what's
And if you don't know, this is the Western aphasia battery picture description task, which is like the cookie theft, but they have to describe this picture in the Western aphasia battery.
going on in the picture and try your best to talk in full sentences.
Okay. That reminds me, looking at one. I would say it's a lake with a building, house, car parked there.
And since it's where I lake, somebody is out there sailing instead of us being out there. I'm not the one that's sitting there drinking and reading. I'd be over on the fish or out in the lake. So, yeah, it's be summer because they've got, the tree is all very much with leaves.
Okay, so clearly the patient improved with 10 weeks of practice of this program. The clinician can see the gains. The patients can also see their own gains. So this is something we call the brain fingerprint that tells them where their starting point was in dark gray and what improvement they've made in light green. And so this is they can see this for themselves and see how much improvement they've made. So that's from the patient's perspective. From the clinician's perspective, so this is a clinician discharging their patients with constant therapy. The first thing that they can do is assign whatever therapy task they want, and they actually can either decide the AI will do it for them, or they can override the AI and give whatever therapy they decide. And so two things I want to point out here is they can decide which level and how many practice, and so you can see different levels, different number of practice items they can, and the second thing is they can decide, they can watch where the patient's starting point is, and if things are getting worse, they can just take it out of the app, and if things are getting better, they can increase the practice trial. So they can do everything they would do in the clinical practice, except now they're doing it on the app. This is their dashboard. This is a clinician dashboard who has several patients that they're tracking. So at a high level, you can see how many exercises the patients are doing and how each patient's doing. And I'll get into these things in a bit more detail. So this is sort of the clinician dashboard. In this dashboard, for any given patient, they can see what that patient's current accuracy is, how much exercise that patient's practice. So in this case, this patient's practicing quite a lot at home. And average activity is 4 days per week. And then they can see the patient's brain fingerprint. This is an actual patient that they can see is getting better over time. And these are all the domains that the patient's working on. And then they can click on any one of those domains on the left side, and it'll open up this window that then shows them where the patient's starting point was and where they are now. And they have a long way to go in that domain to actually master the domain. So here they're halfway point, but in terms of attention, they've actually reached the top of that domain, so they can move on to the next function level there. So this is sort of what the clinician can sort of see and decide where they're making gains, where they still have gains to make, and so forth. Then they can also look at a different view where they can see how the patient's doing based on the therapy schedule. So if they schedule therapy by week and they're checking into the patient by week, they can sort of say, well, this patient's not really doing that well here. But this particular task, hearing words, this patient's gotten better. And so they can say, well, I wonder what's going on there. And so they can click on that green button, and it opens up this window. And this window essentially says exactly what items the patient practiced, what their accuracy was, what their latency was. And if they click on any one of these buttons, it'll open up this window that says this is exactly the trial that they practiced over the course of the therapy. So they can drill down, the clinician can drill down to the level of the item that they can check to see whether the patient was able to do accurately or not. And so then, really what the therapy session with the patient becomes is not so much it's not just practicing the therapy, is let's see what you had trouble with, what did you actually need help with, I saw you really struggle with these pictures, and so forth. And lastly, but most importantly, they can track therapy compliance and adherence. So this is the calendar that they see for every patient. And what they can see here is how much practice the patient is doing. There are a couple of things I want to point out here. First of all, it tells you how much practice in minutes the patient's doing. So some days the patient's not practicing as much. Other days they're doing 30 plus minutes of therapy practice, but they're fairly doing it consistently. The other thing is all of this is practiced at home, because if they come into the clinic and do the practice, it codes it completely differently. So here's a patient who's practicing 4 to 5 times a week, up to 30 minutes a day, and the clinician can see all of this on their clinician dashboard app. Okay, so actually, I'm doing well on time. So that's about all I was going to show you about how this works. As I said, Veer will be here in the afternoon and he can show you more details, but I think this sort of shows what the app is capable of. The rest of the talk, I wanted to sort of tell you the other piece of this, which is because we started this company initially at Boston University and then Constant Therapy spun off, we were able to complete a deal with Constant Therapy and Boston University, where we brought all the data back to Boston University so we could start analyzing the data for the purpose of science. And that's really what I was interested in, is what does this all tell us about therapy and recovery? As you'll see, my research area is really about personalized medicine. So the next set of slides is really just going to be about the data and what we're trying to do in this case. And so some of these studies were led by Constant Therapy, but most of them were led by colleagues at Boston University. And this is all sort of in the interest of what we think about in terms of reducing disability in stroke patients. So for those of you clinicians out there, this sounds fairly, hopefully intuitive. We're trying to prevent, detect, diagnose, treat, and predict the disease. And in this case, we have the opportunity with Constant Therapy to detect the disease, to treat the disease, of course, but also something that I'm very interested in is predicting outcomes from the software. So I'm going to show you some pictures, and I want you to just think about what might be going on. And then when I show you the end of the slide, you can tell me if that's what you were thinking. But here's an older version of the app several years ago. And here's a patient who's actually using the app. And I want you to focus on this here and tell me what you think might be going on with this patient. Here's the actual drill down.
Something went wrong.
Here's the actual. Now, I can tell you, AI can also answer these questions from so here's the data that actually drills down into the specific therapy task this patient was doing. So any guesses? Okay. Hold on to your thoughts, because I'll tell you what happened. So this is a patient who already had a stroke and was practicing Constant Therapy. Had a stroke in 2012, and over the course of the year was practicing religiously pretty much every day, 291 days, 31 tasks, but then had a second stroke around this time. And what happened was the family was watching this performance and realized that the performance was getting worse, that he was unable to do the therapy task. So they actually reached out to us because he had just finished the study and said, something is happening, he's not able to do the therapy tasks. And then we went in and looked at all the data, and indeed, all the performance measures were dropping. So we sent them back to the neurologist. Indeed, he had a second stroke, had some time for recovery, and went back on the app. So here's a situation where you're continuously monitoring the data, you can see a sudden change. And in this particular case, they're looking at decline after a second stroke, but as I said, we're also doing this in dementia, trying to track performance changes over time. So this is an example of detection. There's a lot of studies that have looked at treatment, so I actually will just point a few of them. I'm happy to show you the slide later if you want to go back and look at some of the other studies that I didn't mention today. But the first study that looked at the effectiveness of this platform was back in 2015. where we had 51 participants. It was a feasibility study. We asked 42 patients to be in the experimental group. Only 9 ended up being in the control. It was actually one of those studies where you let the patient decide if they wanted to be in the control, and nobody wanted to be in the control group. But the experimental group got to practice constant therapy at home plus the 1 clinic a week, and the control patients only got the 1 clinic a week session. And our performance measures were the Western Aphasia Battery, the Cognitive Linguistic Quick Test, which is a cognitive test. And as you can see, the experimental group improved on all the measures, and the control group really didn't get better on, these 9 participants didn't improve on most of the measures. What was more telling was that while both patients got the average 40 minutes of therapy in the clinic, the experimental patients got additional 4 hours of therapy at home. And that's what we think drove those differences. So anyway, this was a feasibility study, so we were able to show that you can actually standardize and individualize the therapy, and this approach showed that both severe patients and less severe patients improved. In fact, what we found was patients with lower initial scores actually showed more gains than the higher initial scores here. So this was like the first study. After that, there was a randomized controlled trial. It was an early pilot study that the constant therapy team did. Here they had 32 patients. It was a 10-week study. The key thing about this was everything was done remotely. Not a single patient went into a clinic to do anything. The assessments were done remotely. All the therapy monitoring was done remotely. And the outcome measures were the Western Aphasia Battery, the brief test of adult cognition, and the SAQUAL 39. The experimental patients, there are 17 that got 10 weeks of self-managed constant therapy, so they just did the therapy at home. Every 2 weeks, the clinician would call them on Zoom and say, how's it going? Are you feeling okay? Is everything going along well? And the control group got a bunch of digitized workbooks that were mailed to them, and they also got the biweekly check-in. And what we found was that the experimental group basically improved on all the Western Aphasia Battery measures. In fact, the Western Aphasia Battery aphasia quotient improved 6.75 points post-treatment, but the control group didn't show as much change on the Western Aphasia Battery. Both groups actually improved on SAQUAL, and we can talk about that later, but this is what the result looks like for the WOB. First of all, significant engagement. Patients, there was barely any dropout in the study. Everybody completed the study, and the folks who practiced constant therapy got more improvements. So those were actual prospective studies that were done. Because we have had access to a lot of retrospective data, we have also looked at different sort of questions. So this is work that I've been doing with my computer science colleagues at Boston University. Here we took data from about 2,200 patients within the app who all had post-stroke speech, language, or cognitive impairments. And these folks used the constant therapy application during this time period. So everybody who used this were active for a day in the first 10 to 15 weeks of practice. And then we started aggregating the data. So in this case, it was these different domains, auditory comprehension, so forth. And now we have access to this sort of information, like how old they are, how chronic they are, what their baseline severity is, because this is the information that goes into the app. And we were simply looking at how much therapy practice patients were able to get. We already know they get more practice at home. The question we were asking is how much is good practice? And so just to walk you through this graph, these are the statistical results, but this is the more interesting graph. So here we're comparing therapy practice at home. This is all at home, self-managed, no clinician input. Once a week of practice, twice a week of practice, 3 times, 4 to 5 times a week. And what you can see here is clearly practicing 3 times a week, 4 times a week, and 5 times a week is much better in terms of overall improvement than practicing once a week of therapy. We knew this all along, but this was just compelling to show that you really need 4 to 5 times of therapy practice. So these results, we looked at overall domain score, we looked at within subdomain scores. The results were basically the same. More therapy dosage leads to more improvements, and everything is better than once a week. But in the US, I don't know how it is here, you're lucky if you get once a week of therapy. Most patients don't even get that once they're getting more chronic. So this is really what is the optimal care, which nobody's getting. Oh, by the way, this is the number of subjects in each group, in case you're interested. So we've done other studies like this that I don't really want to go into. I'm actually going to finish early on, so hopefully that's yeah, that's great. So the last thing I want to talk about is how we're now using this data to predict recovery with the algorithm. So this is a different kind of algorithm because it's not the constant therapies algorithm. This is actually algorithms that we're trying to develop to see if we can tell the patient beforehand how much improvement they can expect based on the information that's being developed in this. So again, this is work with colleagues at Boston University. What we're trying to do is build a therapy calculator for aphasia. I don't know if you know about cancer survival calculators and gastric ulcer calculators. It's something like that that's meant to be a patient-facing interface where patients can get information about how much therapy they need to get. So this is a bit of detail here, but I just want you to know that we started this project off with about 18,000 patients. We first wanted to take patients who were not managed by a clinician, so these are self-managed patients because that database is also a fairly large database. From that, we ended up with 11,000 patients, and then from that 11,000 patients, we filtered it based on the fact that they were consistent users of the app. They didn't go off on a vacation between 2 practice sessions, and we could extract features in our machine learning model to predict outcomes. So this is about 2,000 patients that are very clear and clean data set. From that, we built machine learning models for every domain that I showed you in the previous portion, so auditory comprehension, reading, and so forth. And this is just the high level of the machine learning model where you're training and you're training a set and you're validating against an unseen set. But really what we were trying to do here was for each domain, we were calculating the probability of moving from one landmark to the next. So going back to the task I showed you, if so we're doing attention of the card sorting task, the next task would be something different. It was a functionally different landmark, and I'm going to show you that in a second. But because we had, because we were trying to build the probability of of moving to the next level while looking at what features predict the outcomes, we included age of the patient, time since injury, initial domain score, which is a domain score like reading domain score, as well as initial accuracy on that specific task, the number of therapy sessions, so how much practice they get, how long they practice therapy, and if there was a gap, as long as it was not beyond the 14 days, if that gap made a difference in their output. And so what you see here is the model's F1 scores for each landmark and the number of patients, I don't know if you can see the numbers, that positively go to the next level and the number of patients who don't. So obviously the more red the cell here, the better the accuracy, and by the time we get to these domains functional levels at the top, there's not enough data for the model to make an accurate prediction. But essentially what this is saying is the probability of patients to go from one level landmark to the next level is this percentage. In this case, it's 98%. 150 patients move forward, 7 don't. That's sort of what this result is saying. And what this all means is that for the most part, we're able to predict with some level of confidence whether the patients are going to move to the next level or not. Once we finished that, we sort of worked on creating a web interface where patients could go in and put their information. I'm going to show you a demo in a second, but it's basically asking them a bunch of questions. And again, not to get into the details, but the idea is the user goes in here and enters all the information. And as I will show you in a second, once they get to a certain point, once the front end gets a bunch of information, the interface goes to the back-end Amazon service and calls the algorithm which we just developed to then give the prediction in real time for the patient. Hopefully that made sense. So there's a front-end part to it, and then there's a back-end model calling. It calls the model to get that specific prediction for that patient. Okay, I'm going to show you the demo, and hopefully that makes sense. I'll go through it slowly. So this is the demo. This is the therapy calculator web interface. It's on our Boston University website. I can show you the link afterwards. So here the patient goes in, and they enter information about their age, in this case 52. They've had a stroke for 3 months. They pick whatever domain they want. They're going to pick math in this case. And the first thing that it asks them is how well they can do these things subjectively. Okay, so it's doing that, and once it's done, it's getting a subjective baseline of how the patient does. And then it actually says, okay, now let's actually see how you do these tasks that we just asked you about. So now it's asking them to actually do the math for the currency. Okay, so it does this, and then it says, okay, this is all math, so we can progress, we can go beyond this. And it goes on to the next level. So this is what I mean by a functional landmark. This is the next landmark, which is telling time on a clock. So you have to sort of calculate the math thinking forward. Okay, so this is obviously harder for the patient. And this is the next level functional domain, which is even harder math for this person to do. Okay, sorry, pause. So what it did there was it took all that information from the patient, went back to the algorithm that we built, and drew the predictions out for that particular patient. And so now it comes back to the patient, and it says, okay, based on what you told us, this is your starting point, counting paper and coin currency. The next landmark you can go to is using a clock. And the thing it's asking the user is to then say how much therapy they can actually practice, because that's the variable that we can modify. So you see the patient sort of saying, okay, what if I practice 5 days a week? And I practice this for 5 to 6. So here it's saying, yep, that's enough. If you practice therapy 5 days a week for 6 weeks, you're going to go from this level to the next level. The same thing is true. So this is essentially saying the probability of you going to the next level with this amount of therapy is actually sufficient. Now, if this were a different patient, an older patient, 70 years old, had a more chronic stroke, and the same exact parameters, 6 weeks would not be enough. It'll actually take about 11 weeks for them to get to that point. So this is very, very early in its work, but this is sort of what we're trying to do with the data, with constant therapy. Actually, this is what I'm trying to do in my research in general, but constant therapy helps us sort of get to this point of precision rehabilitation. In other work, we're trying to use brain information, but in this case, we are using their language and cognitive profile with the ultimate goal of then predicting individual patients' recovery profile and trajectory. Ultimately, our goal is to be able to tell patients what they need to get better. It doesn't have to be constant therapy. It is anything that they would need. In some cases, it would be intensive individual therapy. In other cases, it would be individual therapy with social groups and vocational training. But bit by bit, step by step, we're trying to build this model so that we can get closer to these outcomes. And today, I just showed you one portion of that. So thank you for your attention. I'm going to stop here and take any questions you have.
Wow, Swathi, very impressive. Any questions? I'll run one if you want. So while people are thinking, I just wanted to ask you, it's a bit technical, but about your back end. I mean, we've got very similar things that we're trying to do here as well. Can I ask you a little bit more detail? When you're making those predictions for a given patient, is it using all of the patients in the back end? Is it weighting them somehow, or is it picking out patients with similar profiles at sort of baseline? Because we know that patients vary by orders of magnitude.
It is for the last part of the prediction I showed. It is looking only at that subset of data of patients who fit that criteria. Yeah. And so in some cases the model can't do a good prediction if it hasn't seen that person before in its data set.
Yeah.
And so that's a limitation. Yeah.
I just need more data. You know?
Yeah.
Okay, so thanks so much for an interesting talk. In terms of memory, one could maybe presume that the approach is largely a restorative versus a compensatory approach. And I was just wondering, is there any evidence to say whether this compared to a compensatory approach makes any difference to everyday memory functioning in brain injury.
I think I understood your question correctly. You're asking if this is more of a practice drill-based approach versus a compensatory function. Is that correct? This program is really focused on drill-based practice. So it's all about how many trials you practice and whether you can improve based on error-full learning, because it's just giving the feedback. As soon as they do it, they find out whether it's correct or wrong, and they move on to the next one. It is not targeted towards compensatory mechanisms, although if patients use cues or tried other approaches, it will calculate accuracy based on however they get the answer right, but it's not looking at what levels, at what level they're compensating to get the job done. I hope that answered your question.
My one's a quick one, so I know lots of people probably have some questions. In the slide where you showed us the tool that you've developed about basically being able to predict kind of what dose someone might need to achieve, you had this 90% figure quoted. And I wonder, is that the figure that you use for all of your data, or does that change? Because 90% is probably something that people can work with, but if it falls, maybe to 60% or something like that, then it's harder perhaps for patients to kind of, interpret what that means to them and in terms of how certain they can be about its
accuracy.
That's a
great question. I don't know if I can go back to the demo, but 90% is the high probability that they will go from one level to the next level. As they're scrolling how much therapy they want, it updates at the bottom, but it will say 60% you need more practice, 70% you need more practice. So it does give them some meaning. And actually, this is where I feel like a lot more work needs to go in, because every time we've shown this to patients, the patients we test this out with seem to know about what's going on, so they seem okay. But if I showed it to a stranger, I think they would get confused with, I mean, the information, the message we don't want to communicate is you're not going to get better. So it's a positive message saying, hey, you're 90% probably going to move to the next level. But that subtle messaging of actually you're not yet going to get better is not fully done in this part. And maybe that's what you're getting at, and we still need to tweak that messaging piece.
So impressive, thank you. I just wanted to ask a bit more about the personalisation of it, because that's really fascinating. How personalised can the stimuli get, or can it be influenced to be really very specifically personalised?
In terms of goals, yes. In terms of stimuli, no. So, and that's just, I think, a matter of time, because I think what you're asking is, can patients upload their family photos and practice? And I don't know, not yet, because the app itself has its super large database. But they can easily, when they're in the app, they can say, I don't like this, move on. I find this too hard, move on. I really like this, stay with me. They can give that sort of personalization of the high-level goals. Yeah.
Hi. If I understood correctly, the data you presented is from an impairment-based perspective that people, if they practice, they get better. Have you seen so far any data with correlation with changes in care needs and care burden and functional changes?
Yeah. I mean, I don't have that data, but it is tremendously positive for people who use it. So the feedback that we get is patients are able to go back to work and so forth. We've just not done a retrospective summary of all of the feedback that is the functional gains. I couldn't tell you about caregiver burden because, again, I feel like that has to be systematically done retrospectively, but I only showed you about improvements on standardized assessments because that's what data I have access to. But there have been other studies that constant therapy has done with hospitals and home health nursing homes, and they report out data from their internal hospital analysis. And these patients, I mean, they go back to work, they go back to their lives, they get discharged from the hospital, and so that's a whole different presentation. It's just I didn't show any of that today.
I was going to ask the same thing about transfer effects.
Hi, I'm Rufus. I work at a small company called New Minds based in the UK, and we're kind of in awe of you at Constant Therapy in a way. We look at you guys quite a lot, what you're doing. So I just had a question about your control group there and your experimental group. So your experimental group had clinician input and it used Constant Therapy, right? And the control group used just the clinician input. Is that correct?
In the randomized controlled trial, the 15, yes, except in both cases, yes. Finish your question. Then.
Sorry, I was just wanting to ask, because we look at this, do you have a group which just used Constant Therapy without the clinician input as well?
Okay, so maybe that's why I wanted to explain. In both cases, they're getting clinician input by way of biweekly check-ins. So the clinician calls them and says, how are you doing? It's been 2 weeks since I talked to you. But even the experimental group is not getting any clinician input for the app. The app just moves them along based on their impairment. In that particular study, actually, yes, the clinician did the initial assignment because they did the Western aphasia battery, and based on the scores, they assigned them the initial therapy tasks, and after that, the app just went on and did their thing. And the clinician didn't try to change anything. They were like, oh, how's it going? Going well or not? So they were, in some sense, just using Constant Therapy. The reason to have the clinician biweekly was to keep the engagement and make sure people don't drop out of the study and have that attention piece to it.
Thank you. I was just going to ask, in terms of the groups that you've been looking at, what is the sort of, I guess, the base, it's not the right word, what's the youngest age that you've been working in pediatrics and adolescents? We're often using adult treatment protocols assessments in adolescents. We don't have suitable ones for our teenagers with varying levels of success. So have you been testing under 18s? Have you tested with adolescent groups at all?
That's a great question. No. This is designed for adults who are 18 and older, but that does not mean people who are younger have not downloaded the app and used it. We just that's not meant for them. As somebody else said earlier, it's not that hard a problem. It's not that hard a technical problem to swap out the existing tasks with more child level, reading friendly levels of tasks. It's just that the company decided to prioritize doing this in different languages, so they've gone off and done this in other languages. But that's the next thing. It's just that I think it has to be very carefully done, especially for the reading level tasks, because there's so many reading tasks here. So it's work in progress, but probably not for a while. Sorry, what other languages? It's in Spanish, because that's a big population in the U.S., and I think it's in British English, Indian English, and some other accent English that I don't remember right now.
Any more questions?
Rosie,
Alex?
quickly, and then we'll break.
Try and be quick. The implementation's fabulous, Swathi. Thank you for your talk. It's being used in the UK. Is it being used in NHS settings? The reason why I'm asking is a little thing called information governance, which is a sort of hell we have to go through. So you've got patient data being sucked into a database. You've got automatic speech recognition, so you've got patient sound files. Have you encountered difficulties like that? And
I don't know. I have no idea its usage in the UK.
On your map, you had it could be used independently.
I don't know if this will work in the UK, but in the US, they have to, each entity. It turns out that in the US they have a deal with the largest rehabilitation set of hospitals there called Encompass. It's not government, it's a private system, and they have a whole agreement with them to maintain confidentiality of their database separately. So there's a whole enterprise software to this that I didn't describe at all, which creates agreements with different companies that hold on to their database in their own silos, and it's not shared with the larger data set. So everything I showed you today is not data that's part of hospital settings and company settings or anything. It's literally people downloading the app and using the app, because that's the only data that we have access to. All the other data is siloed in their systems, and nobody has access to them other than their own their clinicians.
Okay, great. I think there's a chance for more questions at the end and obviously around lunch. So we're going to break for lunch now. We're going to come back at 1:45. And if you just help me thank Swathi one last time. Thank you, Swathi.